All right, so I'm going to be going over free response question one from the 2022 AP Statistics Practice Exam. And so what we got here is a scatter plot describing a biologist that's gathering data on the length measured in millimeters and the mass measured in grams for 11 bullfrogs. And the data is shown in plot one. So here we have the length in millimeters across the x-axis, and then the y-axis is the mass in grams. So part A is saying, based on the scatter plot, describe the relationship between mass and length in context. Okay, so remember that when you're talking about um, a relationship between two quantitative variables, so numbers or values that can be measured in like on a continuous scale, like height, weight, stuff like that. You have to describe four things. Make sure you mention the direction, the strength, the shape, and whether there are any outliers. So, it's positive because as one variable increases, the other one increases. We would say, it's moderate to, I would say, you could probably even say strong. You wouldn't want to say weak, but I think they would give you credit if you said like medium or strong. Linear, my advice is that if it's clear that it's not linear, say that it's linear because they're not going to give you questions um that are really like non-linear because those are for more advanced statistical classes. But to technically figure it out, we would use a residual plot, but they don't give you a residual plot here, so just go with linear. And then there are no obvious outliers. There's nothing that's very clear or very obvious that doesn't follow the pattern. All right, now part B, we have the graph again, and it gives you the equation that relates the length and the mass. So they're basically the least squares regression line for predicting mass from length. And I wrote it here more clearly. So we have y hat equals negative 546 plus 6.086x because x is the length. And part B is saying identify and interpret the slope of the least squares regression line in context. So remember, the slope is basically the coefficient of the explanatory variable or the coefficient of x, which is 6.086. And that describes, the rate of change, more specifically, how much the y value changes for each unit of change in the x variable. So each time the x variable goes up by 1 millimeter, in this case, we're talking about the length, the mass is going to go up by about 6.086 grams. So when they say in context, make sure you mention the length and the mass. That's usually what they mean by context. Now, part C, interpret the coefficient of determination, or interpret the coefficient of determination for the least squares regression line, r squared equals 0.819 in context. So this is basically telling you a percent of variation that we can say this least squares regression line accounts for. Meaning that we know in real life that there's never really going to be two things that are perfectly correlated, like your height versus your wingspan. We know that they are correlated, but we know that you can have the same height as somebody else, but you're not going to have necessarily the same wingspan. But you know that the taller you get, the longer your wingspan is going to get, because we know that even though it's not perfect, that there are going to be other things like your genetics, maybe like your nutrition, that are going to be responsible for like your wingspan, not just your height. This is when the percentage is high, that means it's a pretty strong relationship between, or this line is pretty reliable. It's a pretty reliable line for predicting mass from length. Now part D, we have two parts of D. So it says, based on the plot, approximately what is the length and mass of the bullfrog with the largest absolute value residual? Okay, so we want to look for the distance between any point and the line. And the distance, the greatest distance is right here. Now remember that the points on the line are your predicted values. The actual values are these points, shown, in the scatter plot. So the residual is maybe I should write it over here. So the residual is the actual value minus the predicted. The actual value is about 355. The predicted value, we can find it by plugging in the x value of this point, which I estimate to be about 162. If you put 163, I think again they say approximately, so you shouldn't get anything wrong. Plug in that value x into length for the equation, that'll give you about 440. The value, but they're in this part, they're not even looking for that 440. They're just looking for the length and mass at this point. They're basically looking for the x and y value at this point, which I, again, ballparking it to be about 162 for the length and 355 for the mass. Now, in part 2 of part D, it tells you then, or it asks, does the least squares regression line overestimate or underestimate the mass of the bullfrog identified in part D1? And I say it's overestimating because when you plug in the 162 into this equation, you're going to get about 440 grams. But the actual mass is 355. So then it's a clear overprediction. It overpredicts by about 85. So that's pretty much what they're trying to get at. So I hope that helps, but let me know if you have any questions. Leave your questions in the comments section. I'll try to get back to you as soon as I can. And as always, if you think this is helpful, give me some feedback. And I'll see you guys in the next video.